we're going to start with reviewing some operations on fractions. So we'll start with adding and subtracting. What you need to do when you add or subtract fractions is, if you don't already have a common denominator, get one by multiplying your fraction by some fancy version of 1. So say you have like 3/8 plus 3/4. I also am going to draw a couple pictures here. So if those squares are my whole 1 unit, and my first one is split into 8 pieces, I have 3 of them. My second one, it's only split into 4, so my pieces are bigger, but I have 3 of them as well. I can multiply that second fraction, 3/4, by 2/2 and get a denominator of 8 that matches my first one, which if you kind of split that picture pieces in half, that's essentially what's happening there. Now the pieces are the same size, and you can count up how many there are total. So you have 3 8s and then 6 more 8s, so that's a total of 1, 2, 3, 4, 5, 6, 7, 8, 9 8s. So what they are pieces of size 1/8, and there are 9 of them. So 9 8s is your final value. If you look at B, I'm going to go ahead and change that 3 1/4 to an improper fraction first. So I'm going to multiply 3 times my denominator of 4 and then add my numerator of 1, which is going to give me 13/4. So I have 13/4 minus 3/5. So I need a common denominator before I can actually subtract these. If you kind of list out multiples of 4 and 5, or think about them, 4, 8, 12, 16, 20, 5, 10, 15, 20. 20 is the smallest common multiple. So I'm going to multiply by what it takes to get my denominators to be 20 for each one. So that'd be 5/5 and 4/4. Now remember, by doing that, I'm not changing the value of my fractions. I'm just rewriting them in a different way, because 5/5 is equal to 1, and multiplying by something by 1 doesn't change it. So my 65/20 that I get is still equivalent to 13/4. It's not a different value. So if you actually multiply those to get your common denominator and then subtract, you're going to end up with 53/20. So remember, your denominator doesn't change because you have 53 pieces of size 1/20. Now I want to give two fractions with a difference of 1/20. That means if I subtract them, I should get a result of 1/20. So I'll do a couple up here. Let's say that I do 21/20 minus 20/20. That would give me a difference of 1/20. See if you can come up with a couple more. Okay, now for some multiplying. When you're multiplying fractions, you can just multiply straight across and then simplify if you can. So like this 5/8 times 3/2 is just going to be equal to 15/16. On B, remember your denominator is 1 if it's not written there. So this is going to be 15/6. Now you do have a common factor. If you rewrite those in factored form, they share a common factor of 3. So I can divide 3 by 3 and get 1 and just have 5/2 left. You could also write it as 2.5 would be fine. Another option which can be handy is reducing before you multiply. So instead of multiplying straight across right away, if you recognize you have 3 divided by 6 there, which reduces to 1/2, you can reduce first and then multiply your result across. Another one kind of like before, we're going to give two fractions that have a product so that multiply together to 1/20. I'm going to say 1/4 times 1/5 would work. Then we're going to divide some fractions. So we are going to multiply by our reciprocal, which means on this one, if we have 1/4 divided by 5/6, we're going to end up doing 1/4 multiplied by the reciprocal of the fraction I'm dividing by. So that means I'm going to flip my 5/6 upside down and multiply 1/4 by it, which gives me 6/20, which again you can reduce because you can divide out a common factor of 2 from both 6 and 20 and get 3/10. On B, remember again that 6 is over 1, so I'll have 3 7s, leave the first one as it is, multiplied by the reciprocal of 6, which is 1/6. I end up with 3/42, which those are both divisible by 3, will end up with 1/14. You could also have reduced before you multiplied straight across on those. Now, why does this whole multiplying by the reciprocal thing work? Okay, kind of let me show you here. So we basically want the denominator to end up as 1 instead of another crazy fraction. So if I multiply by, instead of 4/4 or 5/5, by 6/5 over 6/5, then in this denominator, I'm going to end up with 30 over 30, which is just 1. So I have 6 over 20 over 1, which is the same thing as having 3 over 10. A lot of times people don't show the whole entire process here. They just do the multiply by the reciprocal because the bottom ends up being 1 and you get the same result. But that's why it works. So when you simplify mathematical expressions, you need to do them in a certain order so that everything makes sense and everybody agrees on the same result. That order is called order of operations. It's kind of like we're all mathematicians and we need to be speaking the same language so we can understand each other. If you don't do things in the same order as someone else, you're not going to get the same value. So we work inside our grouping symbols first, like inside parentheses or brackets. Then we do any exponents or radicals, working from left to right. So you might have a radical and an exponent, whichever one's on the leftmost side of your expression. Same thing with your division and multiplication, that happens next. And then your addition and subtraction is last. So if you don't have any of those things in there, like no exponents, no radicals, you just skip to the next. You might have heard the expression PEMDAS, or please excuse my dear Aunt Sally, as kind of a mnemonic for remembering what order to do things in. You do P first, parentheses, which is also grouping symbols like brackets. E for exponents, also radicals. It's not my favorite abbreviation. And then multiplication and division. But just because M comes first in this abbreviation doesn't mean you do multiplication before division. You do multiplication and division like the same order of importance from left to right. And same with addition and subtraction. You're doing addition and subtraction, but you're doing whichever is furthest left in your expression and then moving to the right. Not always addition first. So if you look at this one, first we're going to work inside our grouping symbols. We'll add those together and get 7. And then we've simplified inside our grouping symbol as much as we can. So now it's time to move on to exponents and radicals. 7 squared is 49. Now multiplication and division. 2 times 49 is going to get us 98. And then finally, addition or subtraction, we have negative 93. If you look at B, we don't have anything to do inside our parentheses or grouping symbols, so we're going to move on to our exponent. If you square 2/5, don't forget that means you're taking it times itself. So if you don't know what that is off the top of your head, you can write it out and multiply your fractions straight across. Now there's no multiplication or division, it's just subtraction, but when I'm subtracting fractions, I need my common denominator. So I'm going to get that common denominator of 25 and then subtract 4 minus 50 is going to give me negative 46 over 25.